Let's take an example. For this grammar, if the input is given as AABB, which can be generated from this grammar, let us see how this parser, that parsing table, is going to be used in order to generate or in order to verify whether this string is generated by this grammar or not. Always the input is followed by dollar, and first symbol I am looking at is small a. Okay, so we are going to have a stack. Let's say this is the stack, and you have to follow this example very carefully. First thing is, always top of the stack will contain a state, and the first state I am considering is 0 because that is the starting state. Now I'll be in 0 and I'll see a. So 0 on small a is shift 3, which means shift the a and then 3. Shift means this: whatever input you are looking at, you shift it onto the stack, as well as you shift the state number onto the top of the stack and increment the input pointer. Now top of the stack is 3 and you are looking at small a. Now whenever you see again small a on 3, so 3 on small a is again shift 3, which means shift a and then 3. Whenever you shift it, you have to increment it. What is happening is, here we are just remembering that we have seen a and we have seen one more a, and I didn't get any chance to reduce it, therefore you just remember them. That is why I am just remembering them in the stack. And now top of the stack is 3 and the input is b, so 3 on b. 3 on b is S4. S4 means shift 4. Shift whatever is the symbol b and then you shift 4. Okay, and now next I am at 4, which means the state is 4, and I am looking at b. Now the state is 4 and I am looking at b. Then it is saying that reduce with production number 3. What is production number 3? Production number 3 is S derives A derives b. So I have to use the production number 3 in order to reduce whatever I have seen now. So how to do that is, they are saying that you are seeing this b and now you have seen reduce 3. It is actually reducing the previous b. One thing you have to note is, whenever you see a reduce move, actually we are not reducing the current look ahead or the current symbol, we are actually reducing the previous symbol. And in this stack, how could you apply reduce is, see the number of symbols in the right hand side, number of symbols, the length of the symbols which you have to reduce is 1. Therefore you have to actually pop off 2 symbols from the top of the stack. If the size of the right hand side is, let us say x, then you have to pop off 2x number of symbols from the stack. The reason is, if you have to pop off b, you have to pop a stack also. If you have to pop off a, then you have to pop off 2 state numbers. That is why. So now how does the reduce move act is, first you pop off twice the number of symbols in the right hand side and then you push left hand side onto the stack, which means we are remembering that we have replaced this small b with capital A, and then you should always fill the top of the stack with a state number. That is the reason. Just see what is below 3. What is below a? Below a there is 3. Therefore see what is the state that 3 on a should go. 3 on capital A should go to state 6. That is why fill it up here. Okay, one more time listen to this. What happened is, so I was looking at small b and I was in state 4. Now it said that R3. R3 means reduce the b with capital A. Reduce the b, use the production number 3 to do the reduction. Then how are we doing that reduction is, I'll just pop off twice the number of symbols in the RHS. Here I have only one symbol, therefore I am going to pop off 2 symbols and then push the left hand side of the production, which means a, and always fill the top of the stack with a state number. So which state number? Just see what is below a. Below a there is 3. Therefore 3 on capital A, it is 6. That is why I am filling with 6. Okay, so whatever has happened is, we just reduced b to capital A. That is what has happened. Now again we are seeing b. Whenever we see reduce, we are not going to increment the look ahead. We are still seeing b. Now b on 6. B on 6 is saying R2. B on 6 is saying R2, which means take the production number 2. Production number 2 is what? Capital A derives AA, and then reduce it. How many symbols are there in the right hand side of production number 2? In the right hand side of production number 2, there are actually 2 symbols. Therefore, we have to pop off 4 symbols. So what do they mean is reduce this A and this capital A into capital A. That is what we mean to do. Now if we have to reduce small a and capital A to capital A, we have to delete capital A and small a and replace with capital A, which is left hand side. Now if I have to delete 2 symbols from top of this stack, I have to pop off 4 symbols. The reason is, if I have to delete 2 grammar symbols, there will be 2 states associated with this. Therefore pop off twice the number of right hand side, which means AA and then 3A, and then push the left hand side. What is left hand side? Capital A, and fill the top of the stack with the state number. Now you have to fill the top of the stack with state number. How can I fill it? See what is the state below capital A. The state below capital A is 3. 3 on capital A is 6, which means I have to write 6 here. Okay. Now 6 on capital A. See this? 6 on capital A is again saying 6 on small a. 6 on small b. 6 on small b is again saying reduce with production number 2. Which means we have to again use this production to reduce it. A has to be reduced to A. So how can I reduce it? Just we have to pop off all these 4 symbols on top of the stack and then push the left hand side. So pop off the 4 symbols. 1, 2, 3, 4. I have popped off 4 symbols and then replace them with left hand side. What is left hand side? Capital A. And now fill the top of this stack with the state number. What is 0 on A? 0 on capital A is 2. Now you are in 2. Okay. Now see what happens for 2 on small b. For 2 on small b, it is S4, which means shift B and then 4. That is the meaning of S4. And increment the input pointer. Now we are seeing dollar and we are seeing 4. 4 on dollar is R3. What is R3? Reduce it with the production 3. So what is third production? A derives B. So how can I reduce it? Pop off 2 symbols from the RHS and then push the LHS and fill the top of the stack with the state number. What is the state number? 2 on A. 2 on A is 5. Okay. And what has happened here is this B has been reduced to A. Okay, that is what has happened. Now we are seeing capital 5 on dollar. What is 5 on dollar? 5 on dollar is R1, which means reduce with production number 1. So what is production number 1? SD derives AA, which means you have to pop off 4 symbols from top of the stack and then push left hand side, which means finally we are getting this AA is reduced to S. Therefore we got the entire pass tree, right? So we have to pop off 4 symbols. 1, 2, 3, 4 and then push the left hand side. What is left hand side of the first production? R1. Left hand side is S, and then fill it with the a state number. What is below S now? Below S there is 0. What is 0 on S? 0 on S it is 1. We have reached state number 1 and the top of and the input is dollar. Now what is 1 on dollar? Accept it. Therefore we are going to accept it. Now let us examine why it is called LR0. What does 0 mean? We are looking at we are having 0 look aheads. It doesn't mean that we are not looking at any symbol. Actually it means that when we are passing this input string, we did it A, B, B. We have seen A, we pushed it on the stack. Next A, we pushed it onto the stack. Next B, we pushed it onto the stack. And next B, we are actually standing at this B and then we reduce this B to A. Okay, which means whenever I do any reduce move, I am not actually reducing it by looking at that symbol. Whenever I pass to the next symbol, then I am actually performing the reduce. But then if you look at this parsing table, the entire table, right? So it says that if you are in a state, let us say 4th state, don't worry what the next symbol is. Whether it is A, see whether this one is A or B or C or D, don't worry. Whenever you reach that state, you have to reduce it, which means I don't care what the next symbol is. That is why it is LR0. It is called LR0 because we don't care what the look ahead is, what the next symbol is. We are simply reducing it. Because of this there could be some errors. See, now we have reduced a b. No, now what is the string we get is a b. Now again we have to reduce some part of it later into some other variable. What if this b is not in follow of a? Then it cannot be reduced, right? So that is why LR0 is LR0 will allow us to find that error later. We should have looked at the next symbol, which should be follow of a, and then we should have reduced it. But then LR0 says that don't look at the next symbol, whatever the next symbol is, you can reduce always, but then which is wrong. So because of that we might get some errors which will be detected later. And second thing you should note is, whenever we get into any of these blank entries, let us say if you are in state 2 and if you see dollar, or let us say if you are in state 1 or leave state 1 or state 3 and if you are seen dollar, it means that they are errors. So whatever are the blank entries in the table, they always correspond to the errors. So LR0 says that whenever you have a final item in a state, you have to put the entire reduced moves in the entire row. Now there is a small difference between LR0 and LR1. Now what does LR1 say is, whenever you have a final item in a state, don't put the reduced moves. The main difference between LR0 and SLR1 is in terms of reduced moves. Both are using canonical collection of LR0 items only, but coming to the placement of reduced moves, both are different. So observe this. Just understand this. Now I'm talking about SLR1. So SLR1 says that don't blindly reduce whenever possible. Don't blindly reduce whatever is the next symbol. You reduce this symbol to capital A only if the next symbol is in the follow of A. Otherwise what happens is, if the next symbol is not in follow of A, you could not reduce it further to the start state. Therefore SLR1 is bit more powerful because it is taking wise decision in terms of if it is not a symbol which is not in follow of A. So that is why we are going to apply reduce moves, but reduce moves will be done only when the left hand side is being followed. For example, let us say state number 4. State number 4 is having actually R3. See, state number 4 was having, in the previous diagram, state number 4 was having A derives B dot. This is the final item, right? So since the state number 3 is having this final item, state number 4 is having this final item, don't place R3 in the entire row. You just place whatever is the follow of left hand side. What is follow of A there? Follow of A is follow of A. So what is follow of A? Follow of A is first of A as well as follow of S. What is follow of S? Dollar. What is first of A and B. Therefore we are going to place this in R3. So we found out that we have to place this one in follow of A, and follow of A is containing A, B and dollar. That is why I placed it here. And next one is, let us say the next state 5. State 5 is containing like this: S derives A dot, which means state 5 is containing the production R1. We should not place R1 in the entire row in SLR1 parsing table. We have to place it only in the follow of left hand side. Now what is follow of left hand side? Follow of dollar. What is follow of S? Follow of S is dollar. Therefore you have to write R1 here. Okay. And 6 is containing this second production. So what is second production? Capital A derives small a, capital A dot. This is the second production. Where should I place it? I should place it in the 6th row under what? Follow of A. What is follow of A? A, B and dollar. Therefore I have to write R2, R2, R2. So in terms of shift moves and in terms of go to moves, both SLR1 and LR0, both are same. Only difference between these two parsers is where you are going to place the reduce moves, and it turns out that reduce moves have to be placed in the entire row in LR0, which means we need not care what the next symbol is, we have to place the reduce moves in the entire row, right? And in coming to the SLR1, don't place the reduce move in the entire row, just see that the next symbol that you get after reducing is in the follow of left hand side or not, which means don't place the reduce move in the entire row, just place it in the follow of left hand side. The reason is simple, even if you reduce it, later it has to be see, in this case, let's take this example. In this case, what is this production? R1 is S derives AA, which means whenever you want to reduce AA to S, see that S will be reduced to S dash later. So if I reduce AA to S in this string, if I have AA and if it has to be reduced to S, which means it is end of the string, then it has to be followed by dollar. That is where I got this, isn't it? This entry says that you can reduce AA to S provided that next symbol is dollar. That is why we have to see that the next symbol, the look ahead, is always in the follow of left hand side. That is why it is also called as SLR1. 1 means number of look aheads are 1. Okay. So we are looking at one look ahead and then taking the decision. So which one is powerful? SLR1 is powerful. The reason is SLR1 is having less number of reduce moves. Therefore, if there is any error, SLR1 will detect the error faster, very fast. But LR0 will actually detect the error slower, which means it will not be able to find out that there is an error because all the entries are full. So number of error entries depend on number of blank moves, and number of blank moves are more in SLR1. Therefore, SLR1 is powerful because it can detect the errors earlier. Okay, and how to implement the errors is, in place of blank entries, you can have pointers to functions. So whenever you hit that entry, we can call a function, and that function will take the move. Sometimes what we would like to do is, we don't want to stop the parsing, we want to continue it. In that case, the function will take some action, like it will assume that whatever symbol is missing, it will put it there, or whatever is the symbol, it will just assume that it is there, and then it will go continue, or something like this. Or it can even print some error message saying that something is expected, A is expected, B is expected, or here A is not expected, B is not expected, something like this. Okay. Now we have seen two parsers, two types of parsers. One is LR0 and other is SLR1. And we observed that if I have a state, let us say this state is, let us assume that I5, then whatever are the transitions going out of it, for all those transitions we have to fill the state number or the row number 5, right? And we have seen that if there is a terminal, then this corresponds to the move. If it is going to, let us say, I6, then it corresponds to the move S6, right? And we have seen that if there is a production which is final item, A derives alpha dot, then it corresponds to reduce move. Now I am talking about LR0. Is every grammar LR0? Every grammar may not be LR0. The reason is, there could be a chance that it is, if I have something like this, which means in a row number 5 I am going to some state on S3. Therefore, in the action part, forget about go to part, in the action part under A in the 5th row I am going to write S6, which means we are going to 6, right? And along with this S6, I might have to put the reduce move in the end. Let us say AB are the terminals. Now what happens is, because of this final item, I might have to put the reduce move in the entire row, which means I might have to put something like R1 because of this production number 1. So now this is called a shift reduce conflict. Therefore, all the grammars are not suitable for LR0 parsing. The reason is, there could be SR conflict, or there could be one more chance of getting like this. Let us say this is the grammar, this is a state I5, some state, and now there are two productions, A derives alpha dot and B derives beta dot. If I have two productions like this, alpha dot and beta dot, and let us assume that this is production number 1 and this is production number 2, then what happens is, in the state number 5 in the table, if I have terminals A, B, C, then I have to place R1, R1, R1 for this first production, as well as I have to place R2, R2, R2 for the second production. Therefore, if there are more than one final items, the grammar cannot be LR0 because of RR conflicts. We cannot have two entries in a cell. This is called RR conflict and this is called SR conflict. So understand this, a grammar cannot be LR0 if I have RR conflict or SR conflict. And what is the chance of getting a SR conflict in LR0? Whenever there is a shift move as well as a final item, then I might get a SR conflict in LR0. And whenever there is a two reduced moves, then I might get RR conflicts. Whenever there are two final items in the same state, then I get RR conflicts in the LR0. Now what about SLR1 then? SLR1 is a bit different, right? In SLR1, we get a SR conflict in this state. Let us say this is the case, and in this case it might not be a SR conflict. The reason is we are going to small a, on small a we are going to 6, therefore definitely here I am going to write S6. But then reduced move may not be present under small a. The reason is we are going to place reduced moves in SLR1 under the follow of left hand side, and if the follow of left hand side doesn't contain small a, then it could be SLR1. So in case if this grammar should is not a SLR1, or if you have to get a SR conflict in SLR1, let us say SLR1 grammar parsing table. Now if I have to get SR conflicts in SLR1 parsing table, then the possibility is, one thing is you have to see the follow of left hand side. What is follow of left hand side? Follow of A. If follow of A contains small a, then only this reduced move will be placed under small a, and already there is shift move, then only we are going to get SR conflict. And in this case there will be RR conflict in SLR1 parsing table if there is any intersection between follow of A and follow of B, because R1 will be placed under follow of A and R2 will be placed under follow of B. Therefore if there has to be any let us say a conflict, RR conflict, then follow of A and follow of B, they have to intersect. In case follow of A intersection follow of B, if this is not equal to 5, then only the grammar is having RR conflicts. So in LR0 the grammar is having SR conflicts in case if we have any problem with follow of A and shift A. And in case if there is any intersection between follow of A and follow of B, then only we get the RR conflicts, otherwise we don't get it. Now I'll take some grammars and we have to check whether they are LR0, SLR1 or not. Okay.